Good morning, fifth graders. Ms. Jagodnik here. I'm here to talk to you today about percents. Percents are something that you probably see the most when you get your grades. When you get a test back and you got an 80, that is really 80%. What does that mean? It means that you got 80 points out of 100. So even if the test didn't have 100 questions on it, which hopefully it didn't because that would take you forever, people are figuring out if there were 100 questions, what part of that 100 points would you have gotten based on the number of questions there were. So to find that percent, what we really need to do is figure out what fraction of questions did you get right, and then turn it into a fraction over 100 by using what we know about equivalent fractions. So that's what we're really doing when we're working on percents. It's a ratio, it's a comparison written as a fraction. And then I'm going to turn it into an equivalent fraction that would be out of 100 and use that fancy little percent sign you get to use. Okay, so today we're going to work on finding percents on page 907. We're going to do the guided practice, and then I've picked out a couple of the independent problems that were a little bit trickier too, so I thought we could go over how you might do a problem like that as well. So starting with the guided practice on the top of page 907, first they ask you a couple questions to think about and explain. So let's look at number 1 here. 4 out of 5 people prefer bright white toothpaste. What percent of people is that? And so 4 out of 5 people. So we know another way to write that as a fraction is 4/5. Okay. If I want to know what percent that is, I'm really saying is, hey, if 4 out of every 5 people prefer this toothpaste, what if I asked 100 people, how many of them would that be? So I want to change it into something over 100. So what I'm doing is times something over something equals a fraction out of 100. So I want to know, what am I multiplying 5 by to get to 100? Because that's what I'm multiplying by. If I have 4/5 and I want to change it to hundredths, 5 times what equals 100? Well, 5 times 2 equals 10. So 5 times 20, annexing that 0, equals 100. So if I'm doing the denominator times 20 to find an equivalent fraction, that means I'm also doing the numerator times 20. So I'm really doing 4/5 times 20 over 20 gives me something over 100. 4 times 20 is 80. So I can see that and say that 80%, here's my fancy little symbol, of people prefer bright white toothpaste. 4 out of 5 is the same as 80 out of 100. So instead of calling it 80 out of 100, I can call it 80%, because anybody seeing the percent sign knows, oh, it's a percent. That's what it means. It's out of 100. Okay, number 2. Where else does cent mean 100? Okay, this is a little thought question. Let's go back to geometry where we talked about how certain word parts like quad and lateral and equa mean something. And that can help you figure out the meaning of a word. So when I see percent, there's a clue already in there. Per, cent, each, 100. So this is out of 100. Where else do I see the word cent? Well, the first place I see it, of course, is money. There are 100 cents in a dollar. Another word I think of right away is century. Okay, century is a group of 100 years, like the 18th century. Centipede is another one. Centipede is a bug that has all those legs on the side, and legend has it there's 100 legs. If you read James and the Giant Peach, kind of argues against that. I'm not sure if there's actually 100, but that's why it was named a centipede, because it looks like at least that it has 100 legs. If you can think of any others, I'm sure there's a bunch more where you can think of the word part cent and it has something to do with 100, but those are a few examples. And now we can go on to number 3. What are 2 denominators that are easy to change into 100? Okay, so like we just did, we have to change something into 100. Obviously, I want denominators that are factors of 100. The 100 is a multiple of this number, so I can multiply it and change it into 100 evenly. So let's see, what's easy to multiply and get an answer of 100? Well, 50 is one I think of right away. 50 would be nice and easy because 50 times 2 is 100. Something like 25, like quarters. I know that 4 quarters are in $1, so 25 times 4 gives me 100. Oh, so I guess that means I could also go with 2 and 4, because if I know 25 times 4 and 50 times 2, I could also do it in the other way. 10 is going to be easy to change into 100 because I know 10 times 10 is 100. So those are some of the ones that maybe work out a lot easier than others, mental math. All right, now let's do some examples where we're looking for percents. What percent is not shaded? That's what they want me to find in numbers 4 through 6. I have shaded pictures and I want to know what percent is not shaded. So let's not get fooled by that. No splashing here, my class. Not. So I don't want to look at the shaded part. I want to look at the blank part. So here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4/10 is shaded, which means not shaded is 6/10. I want to change that into hundredths so that I can figure out a percent. Oh, good. That's one of the numbers we just said would be easy to do that. I know that 10 times 10 is 100. So I also have to multiply the numerator times 10 to make an equivalent fraction. So that gives me 60. 60 out of 100. So that means 60% of this figure is not shaded. Number 5, oh, look at this. It's already a 100th grid. So that means that I already have 100 spaces in here. I can see that 1, 2, 3, 4, 5, 6, 7 of them are shaded, okay, out of 100. So that must mean 100 minus 7, 93 out of 100 are not shaded. So that means this figure has 93% not shaded. You see what happened there? We already had 100 as our denominator, so I don't need to do anything, no equivalent fractions. I just use the percent sign instead to call it a percent. Okay, next one, number 6. Oh, I see I have 10 circles altogether, and 1, 2, 3, 4, 5, 6, 7, 8 of them are shaded, which means 2/10 are not shaded. Well, look how easy this is. We already worked with these numbers. So I know times 10 over 10 gives me my hundredths. 20 out of 100 would not be shaded. So that means for this figure, 20% is not shaded. Okay, so that's the quick and easy way to figure out percents. You're just changing it using your equivalent fraction strategies into a fraction where the denominator is 100, and then you can just replace that denominator with the percent sign so that you can use it as a percentage. Now we're gonna look at a couple of the trickier problems. The rest of this page and page 908 are your independent practice, which you can try on your own. And then any questions or confusions you have, you can ask your teacher about the next time you meet with her live. But right now, I just wanted to make sure we took this time we have together to look at a couple of the ones that I thought were tricky going through the first time I looked at them, so that you have this example going in and maybe that can help you figure out some of the others. So at the bottom of this page, there's a section where they ask you to figure out what these various fractions would be in percent. And we know that means I need to change it into a fraction over 100. However, when I look at 19 and 21, those were the two that I had trouble with at first, because this 8 on the denominator is not one of the numbers we said would be easy to change into 100. And in fact, 8 does not go into 100 evenly. So this is a real problem in terms of changing it into a percent. If I tried to change this fraction, something over something equals 100, then I can't do it. If I think of my multiples list, 8 times 11 is 88. That's where I'll start with my landmark that I know for good. So 8 times 12 would be 96. 8 times 13 would then be 96 plus 8 more would get me to 104. So when I go on my multiples list of 8, Okay, that means 8 does not go into 100 evenly. Okay. So I can do a couple things. I can use some reasoning and say to myself, well, gee, if 12 gets me to 96, which is 4 steps too low for 100, and 13 gets me to 104, which is 4 steps too high for 100, then gee, my goal must be right in between. So what is between 12 and 13? Seems like it would be 12 and a half. So reasoning wise makes me think that this answer is about 12.5%, but I don't like to just think and guess. So I want to think of a way to check that for sure. And remember, fractions are division. So if I'm talking about 1/8 of 100, I can figure that out exactly by taking 100 and dividing it into 8 equal parts. So let me try my division strategy and divide 100 into 8 parts and see what each part would be. So just forgetting this for now, I'm going to go over here and set up my division. 100 divided by 8. Well, I know I can't do 1 divided by 8, so I'm going to start here at 10 divided by 8. 8 goes in once. That's 8, and I have 2 left over, and I can bring down my 0 ones. So 20. 8 goes into 20 2 times. That's 16, and I can subtract, and I have 4 left over, and hence the problem, I have a remainder. Okay, but we know I don't have to leave it that way. I can put a decimal point here, and I can extend my long division process. So I can bring down the 0/10 and make 40. Oh, that's nice, because 40 divided by 8 works out evenly. That's 5. 5 times 8 is 40, and I have nothing left. It comes out evenly. So my answer to 100 divided by 8 is 12.5. So 1/8 of 100 is 12.5. So I could actually give my answer that way as a decimal and say that 1/8 is 12.5%. But thinking back to my reasoning, I was thinking it's got to be between 12 and 13, so it's probably 12.5. Does that make sense with 12.5? It absolutely does, because 0.5 means, we know from our decimal unit, 5/10, which is the same equivalent to 1/2. So I could also call it 12.5%. Okay. Now moving over to 21. 21 is related. I'm still working with the 8th. Okay. But this time I want to find out, what if 3 out of 8 people said something? What percent of 100 would that be? So if I do 3/8, well, I would have to divide by 8 again and then multiply times 3. But we already know what the divide by 8 part is. We know it's 12.5 or 12.5. So now all I have to do to get 3/8 is to triple that. Okay, so 12 tripled is 36. Okay. And then the 1/2 tripled would be another 1.5 or 3/2. So if I put all of that together, it's 37.5%. If I want to do it as a decimal, okay, then I could call it 37.5%, because I could say, okay, 12.5, that's 36, and another 1.5 would be 37.5. All right, so those are some of the trickier calculations you might have had to work on. I also wanted to look at the thing that's always tricky for us, that higher order thinking problem on page 908, because it's kind of asking you to go the opposite way. Marta's line segment is 3 inches long, and that is 50% as long as Jones. So how long is Jones? So notice they've flipped it a little bit on you here. Instead of saying, here is a fraction, what percent is that? Now they're saying, here's an answer that is this much percent. So what would the other one be? So we're kind of going backwards. I know it's 50%. I know 50% is 50 out of 100. I want to know what the actual length of her line segment is. And this line segment wasn't 50. So her line segment is not actually 100, but it's the same ratio, the same comparison, the same relationship. So it's equivalent fractions, just like we've been doing up here. So instead of saying 50 over 100 times something over something, and no, now I'm going to say 50 over 100, 50%, is equal to her line segment 3, because her line segment is 50%. That's 3 out of what? That's what I've got to figure out. 50 out of 100 is 3 out of what? Okay, so I could try and go from 3 to 50, but that doesn't work out evenly. So I'm thinking I might want to make this easier for myself, because when I look at 50 out of 100, right away, I think to myself, that's not simplest form. 50 out of 100 is a half, because I know 50 is half of 100. So if I change this to simplest form, I'm going to say that she has to be equal, this comparison has to be equal to 1/2. So if she has 3, then what must Joan have for it to be equal to a relationship of 1/2? That must be a 6. Okay. Joan's line segment must be 6 inches. Okay, remember when we talked about ratios a couple days ago, that one way you can give a ratio is a fraction, and you can put it in simplest form like any other time we use fractions. So if I see something like 50 and out of 100 and I notice, gee, that's not easy to work with, I might want to think to myself before I go too crazy with my other strategies, is there a simpler form that would be easy to work with? Because 1/2 is easy to work with. I can get from 1/2 to 3 over something very easily. So that's something else you might want to think about when you're doing these more complicated problems. Also, just note for the future, 50% is half of something. It's always 50 out of 100 is always equal to 1/2. That's just one of those things like 4 quarters in a dollar or 7 days in a week that you should know. Oh, 50%, that's half. Because that comes up a lot in life. Just like you know 0.5 when you see it in a decimal form is 1/2 without having to do all the math. The same idea should come to you when you see 50%. Oh, that's a half. Okay, I hope that helped, and you can do the rest of 907 and 908 on your own and bring any questions you have to your teacher when you meet live, and I will see you again in a couple of lessons.